All right, hello everybody. Thank you for coming along. Nice to see some friendly faces that I know. My name's Jacob. I work for NVIDIA. I've worked for NVIDIA for a while now on open source projects primarily. And before being at NVIDIA, I've worked on like a bunch of open source projects in the Pydata space. Some of them you might have heard of, like Dask. More recently, I've been drawn into OpenClaw and been working on that. So, you know, if you want to talk about that in the pub afterwards, that's some wild times. But what I want to talk about today is documentation, right? We're all moving in this direction of using coding agents for everything, it seems. And I've spent a lot of time over the last 10 years or so, I guess, thinking a lot about documentation and how to write things in a way for people to come and consume in open source projects. And that whole world is kind of shifting a little bit. And so I want to take some time in this talk to kind of unpack some of that and talk about like what that looks like in the future. I also kind of need to caveat this to say I just got off a very long flight. I've over-caffeinated in response. So if this is a bit frantic, then I apologize. But hopefully it'll be interesting. So as I say, in the past, your users would come to your project. They would hear about it somehow. Somebody would tell them. They would see some code that uses your library. And they would go and read the documentation to understand more about it. Now, who here works on software libraries or code that gets consumed by other people, and therefore you have to write documentation for them to use it? Okay, good bunch of people. So the thing that we find now is often instead of people going and learning about interesting software libraries and then going and reading the documentation and going and using them, you just go to your agent and you talk about the goal. You talk about the problem you're trying to solve. I want to get to this endpoint. And it goes and figures it out, and it goes and uses some software libraries, and you might review the code, but unless you make very intentional decisions, you delegate that over to the agent, and the agent makes decisions on how to read that in different ways. So, in this kind of new future that we're in, although our communities are still made up of people that are using our software, like the agents are acting as this middle intermediary, and everything is getting translated through them. And so we need to make sure as library developers that we are publishing things in a way that is going to work well with these agents. Otherwise, we're going to lose our user bases, basically. I think people are going to start clumping into the larger projects, and maybe more niche projects will get lost. So let's talk for a second about how agents make these choices about how to solve a problem. These models are massive, right? They've got billions of parameters. They've read everything, and they make decisions initially just based on their weights, based on their training. Right? What data was in that training set kind of informs how it thinks about things, how it reasons about things. So if I ask it to go and do a certain task, and there's a library that's well known for doing that task, more so than other libraries, it will go and use that one, right? It's overweighted within the training set. It will just go off and use those libraries, even if they're old, even if there's better or faster ways of doing things. The other way that it goes and learns is if for some reason it's been instructed not to do that, if it's been given some guidance or some instruction about go and use this tool, go and do this thing, it may not know as much about that. There may not be as much inherent knowledge in the model about that library. And over time, as we publish things and we write blog posts and we write documentation and the models consume those, and in their training, pre-training phase, that knowledge is going to get baked in. But ultimately, when you run your Claude Code session or Codex or whatever it is you're using, it's going to go and learn. It's going to go and read. It's going to read files and ingest them into its context window so that it can then generate more code based on that stuff. So you have this like pre-training phase and this kind of inference time phase of learning about things. Now, I ran this little example before. If you just go and grab the like generic titanic.csv data set that every like data science 101 course uses, and you just throw it into Claude Code and you just say, analyze it, and ask it to do some operation like, can you group this data set by 2 columns or something? It will just go and it will go, pandas. Everybody knows pandas. Everybody loves pandas. I'm going to go and use pandas to do this operation. Although actually, you know what? To make this is a contrived example. Because when I first did this and I just gave it that prompt, it just re-implemented group by using the Python standard library. And I was like, whoa. It was super slow as well. I was like, okay, don't do that. Like maybe we should. I like re-prompted it a few times. It was like, analyze this data really fast, do it really efficiently, and like trying to nudge it in this direction. And it kept like trying to optimize its little terrible script. And it was like, I was like, how would you, if I asked you to do this efficiently, how would you do it? And it was like, I would use pandas. Ah, pandas. And then it like went off and did this thing. And then that went into its memory. So the next time I asked it, it was like, pandas, I'm going to use pandas straight away. But the point here is that like pandas is very well represented in the data frame space, within the model weights, within the community. And so if you ask it to do these kind of things, it will use pandas. Even if you are a Polars fan or you want to use something else, right, the default behavior is to use the kind of standard. Yeah, I just said all that. So one thing that you see people do is say, OK, I am a Polars fan. I know Polars. I like Polars. I appreciate the benefits of Polars and what it can do and the fact that it's lazy and all these different things. So I'm going to tell my agent to do that. So maybe on a project that you're working on, you might have an agents.md file or some skills or something where you add an instruction there to say, you should use Polars. Right, now, Polars is, again, probably not a great example for this because Polars is quite well known. The model can probably write Polars code without reading anything. It's probably already in the weights. It's a very well-adopted library. It's very popular. There's lots of blog posts, lots of documentation. All the modern models will likely know about that. So what if I make some new library for doing data analysis on CSV files, or some library to do anything? And I put a little slide here together just to show, what if I make a new library called Super CSV, and I say to my agent, go and use Super CSV to analyze my data set, right? It doesn't know about this thing. And this applies to if you work in a large company and you have internal libraries or like proprietary libraries or anything like that, the models won't know about these things. They're not these big popular open source projects. They are internal projects. And so in order for it to work with that, it has to do all of its learning at context time, right? It has to go and figure out how to use this library and how to build things. So if you've tried this in your agent, it follows a pretty standard set of its steps, which is not how I would learn about a library. Right? It generally, pip installs the library and then just reads the code. Right? That is kind of how it approaches it. And I wouldn't read pandas to learn pandas, but this is how most of these agents approach things. Is that first initial thing, and it will just literally search through site packages like, oh yeah, I've got that installed. I'm just going to go and have a look in there. Now, a lot of packages also ship their tests along with the code, and so if there's tests in there, it goes, oh great, I'll read all the tests as well. There's probably loads of examples in there of how to use the library. But it's going to read all the mocks. It's going to read all the mess. It's going to read all the, I don't know what your guys' tests look like, but mine are not how I expect users to use my code, really. And then, really, it's probably not got a README in that bundle that's on your system for that library. There's not a huge amount more information other than that. You might have some metadata that's come along with a package, and maybe you have got your markdown files in there. Maybe you don't. But it will go and try and find that. So the next thing it will do once it's had a look through that is it will go and do some search. And they often like reach for the search tool first, and you'll see them do this kind of thing where it's like library name, thing I want to do this current year, just to try and find modern tasks. So it might search something like Super CSV Analysis 2026. That search will turn up some stuff. Hopefully, it will turn up the documentation for your project, maybe. Or it might turn up some blog posts, or it might turn up the documentation for some other project with the same name. There's like a whole world of doing like SEO targeted at agents that are going to go and read these things. I don't want to dive too much into that because like SEO is a whole black magic world. And ultimately, the search tools that these agents are using are very similar to the way that normal search engines work. And so all the same kind of principles apply. Doing SEO for humans and doing SEO for agents there's a lot of thought going on there. But ultimately, I want to think about once you get to the documentation, like what next, right? So if it finds the documentation, it finds the documentation, it will read a bunch of stuff and learn about the project. But it really focuses on that local use case first, okay? And so when it goes into the site packages, often the first file it will open is just the init.py. When you say like it reads the code, like it navigates the code from the top down from that import level. So it will open init.py and say, what's in here? It will look at that _ all to be like, what submodules are in here? What's being exposed? And that's not necessarily a great entry point because not every library, especially like internal company libraries and things, you might not have that rigor around how you define things. you might not separate your public API and your private API particularly well. Even in big open source projects, like I work on some big projects that are very well adopted that don't have clear like public-private API boundaries that have kind of bitten us over the years, and something we always work on. But like it's the same kind of trap that the agent is going to fall into, right? Is kind of trying to crawl through the code and navigate through the code. It's going to find all sorts of internal stuff. It's going to find things that are not expected. And something that we talked about a lot in Dask as we've worked on it over the years is what is the public API and what is the private API? And that project started a very long time ago. It didn't have very good rigor around keeping those things separate with underscores and like Python naming conventions. And the thing that was kind of adopted by the maintainer team over the years was if it's documented, it's public, and if it's undocumented, it's private, right? Not ideal, but it's the reality of many projects is they make choices like that. But if the agent's first exploration of it doesn't know the documentation exists and it just reads the code, it has no idea about that public-private boundary. So it's likely to use private methods, and eventually that code will break. But it will go and import things that will start reading through your init.py and see what's in there. So my first piece of advice to everyone is just tell it where to go in there. Put in your header, like this is where your documentation is. It's hosted on GitHub. Here's the rest of the source. You can go find the issues. And ideally, like here's some local documentation too. And I'll come on to that more in a minute. But given that it will reach into the init.py immediately before it does anything else, when reading locally, just tell it where to go next, right? And there's this whole concept in working with coding agents called progressive disclosure. You may have come across this term. This is kind of an old term that's been used a lot in interface design. But it's the idea that you give the user, or in this case the agent, like a little bit of information about the task that it can do. You give it the things it want to reach for immediately, like right up front. Say you've got like a settings menu, right? You're on your phone, you swipe down. You've got the things you reach for often, like Wi-Fi and Bluetooth and like common settings. And then you have like more. You can click more, and then it's grouped by subcategories, and you can kind of drill down. And you don't know exactly where the setting is, but you can kind of find it. It like gives you breadcrumbs to trail through and figure things out. Lots and lots of web interfaces do this. This is like a standard thing in web design, is like how to give your users not like a big, overwhelming, like Chinese takeaway menu of everything you could possibly do, but just like kind of lead you through all the different features of the application. The same thing applies when you're kind of walking through context and trying to learn and discover things. So instead of giving your agent like a whole load of context, you might give it like little sentences, little descriptions. If you want to learn about this, go and read this thing. If you want to learn about this, go and read this other thing. Like we've written all of our API reference over here, and you give it like a map, almost like a sitemap of your resources, and then it can go and follow those. And I think when working on documentation, it's so common to think of our documentation is the docs folder in our repo. That's where our documentation is. We have a README and a docs folder, and that's everything. But if the first thing that your agent hits is the doc string in the init file, like that is your documentation too. And you need to think about like, well, that's the entry point. That's the top level. We're going to go off and reveal from there, like, where do I go next? The agent will decide where it goes next based on what it finds. So start building a breadcrumb trail through your documentation so that your agent can discover things starting from that point. Okay, so once you've thought about this concept of everything that the agent touches kind of becomes its documentation, whether that's the code, whether that's the actual documentation you've written, we can start thinking about how to improve that, right, and how to make your whole project kind of more agent readable. And one big thing that has taken off a lot more recently is just publishing basic Markdown, right? Instead of, as well as publishing HTML documentation, you also publish Markdown documentation. Because when an agent goes and does a web search for your project and it finds your documentation site and it reads some page, it reads all of the HTML. There might be some stuff in the harness to try and like filter out and find like what's the body of the document, and then I'm just gonna, there's some like efficiencies to be gained in there, but like HTML is not necessarily the best input data to a model when you can just give it Markdown, right? But the Markdown that you write, or maybe you write restructured text, or maybe you write something else to document your project, you have like source of your documentation, and then you have the like final output. So you have a folder called docs, and in there is a bunch of Markdown files, and all your documentation is written in Markdown. but they might like link to each other using like a Sphinx-specific syntax or a MakeDoc-specific syntax. You might have directives or extensions or plugins or whatever in your documentation that automatically expands API references or templates something in, or uses AutoDoc or into Sphinx to like cross-link other pages. You have all these different things in your documentation. And so what you really want to do is you want to take that input and build it into some final output. And commonly we do that into HTML and PDFs and EPUBs and whatever kind of human formats. But we can also just build that to Markdown again, right? But you now have like a kind of rendered out, rich Markdown with everything in it that is kind of a good input for an agent. And there's a movement that's kind of started maybe 18 months ago called LLMs.txt. You may have heard of this. This is an idea of having at the root of your website, of your domain, you have an LLMs.txt file. And in that file, it has kind of a sitemap in Markdown of this is everything in the website. And that sitemap links to different pages. And you have, for every HTML page you publish a Markdown page as well. It's just the same URL, but with .md on the end. And so the agent can go and just read that one directly. It can hit your LLMs.txt, discover what's on there, hit other pages, pull those in. There's also an LLMs full.txt, which is just like all of website in one file, which on small projects is fine. If you've got a little library with a small set of documentation, you can probably fit all that in one file and it doesn't take up too much in the context. We did this on Xarray, if any of you have used Xarray, and like the LLMs full.txt was like 3 megabytes or something, and it's too much to load in right into a model. But you'll find whatever kind of documentation tool you use, there's probably an LLMs.txt extension for it, so you can just very easily enable it. Just a plug personally, I wrote this one. It's called Sphinx LLM. If you use Sphinx, you can go and just install the Sphinx LLM extension, and it will, as part of a normal build, it will build out a full Markdown version of your docs as well. It works by, there's already like a Markdown engine backend for Sphinx. So this just runs your normal build and the Markdown build in parallel, and it merges the build outputs, and it puts all the files where the spec expects them to be in terms of their URLs. But you get that kind of rich output. You get all of your extensions rendered, you get all your directives and everything in there. And there's some other kind of bells and whistles in Sphinx LLM, like having that sitemap, that LLMs.txt page, you want kind of like a link to the page and a description of what's in it. A link to another page and a description of what's in it. This will, if you want it to, it will write those descriptions for you. So as it goes through all the pages building them, it will generate a small summary and like kind of dynamically generate the sitemap using a local model or some hosted model, whatever you want to do. And it also has some support for I find quite a lot in documentation that I cross-reference one page to another, but I almost want like a little snippet of it, right? It's like, oh, this page talks about this topic. Here's like a 2 sentences that's enough for you now. And if you want to learn more, go and read this thing, right? And so you kind of have like a little summary and a link. But if that page then changes or you modify it, that summary may get out of date or might get stale. We see this a lot. I work in this group at NVIDIA called Rapids. We build like GPU accelerated Pydata libraries. And we have this whole set of documentation for deploying workloads that use these libraries. And so we've kind of built that documentation out in a way where you have kind of cloud vendor specific pages. Here's how to install the stuff on Google Cloud. Here's how to install it on AWS. Here's how to install it on Azure. Here's how to install it on Databricks, whatever your platform is. And then we have other pages that's like, oh, I want to use Rapids to read some data from S3 and then do this kind of whatever the data science workload is, and then I want to store some results somewhere. It walks you through like tutorial style, but it kind of mentions specifics about different clouds as you go through. And so it cross-references the like vendor-specific pages with the example-specific pages. And then one of the vendors will change their platform a little bit. We'll go and rework that page to make sure it will still make sense. And then the example notebook will be broken or something because it has some stale instructions. So Sphinx LLM will go and like read the documentation page when you build the Sphinx site, and then it will just use a little lightweight LLM to just generate summaries and embed them straight in. So there's like a bunch of fun features in there for kind of using LLMs as part of your build process. But the meat of it really is I want to take my documentation and publish it in a format that an LLM can consume easily. But the last little bit of this is it's great for you to go and publish it on your website, your documentation website, but why don't you just put it in the code as well and just like give it to the user, right? Take all of this Markdown that you've built and put it in the wheel and push that to PyPI so that when you pip install pandas or whatever it is, you get the code, and you also get these markdown files that has the full set of documentation. There's a load of nice benefits around this. One is that you don't have to go and hit the web at all if you don't want to. The LLM can stay on the machine. It can reduce the number of queries it's making. It can go much, much faster because it's just reading local files. And it also means that the version of the documentation you have locally is the version of the documentation that matches the code that you have. So it's not going to go and read latest, and you're on like 2 versions ago, and it goes, oh, I'm going to go and use this function, and then it finds out that function doesn't exist yet. And you must have seen your agents do this in the past, right? And you just watch it for a little while, and it's like, I'm going to try this. Oh, that code doesn't work. Oh, that function's missing. I read the wrong documentation. I'm going to go and read this other documentation over here. Ah, that function exists now. And it like rebuilds it, and you can watch it doing all this thinking. And you just think, if you just had the up-to-date documentation on my laptop initially, that would have saved a whole load of tokens and stuff. And the other nice thing is like Markdown is super cheap to ship, right? It's just text files. It compresses really nicely. All the wheels are like zipped and stuff. Like it doesn't add much. I remember the days when we used to really stress about what went into the package because lots of projects would accidentally ship the code and their tests and all the data that's needed for the tests. I remember I had some pipeline that I set up at one point that installed a bunch of Python libraries, and it installed SciPy. And then we had this extra script that was like, just go and delete all the tests and nuke all the stuff, and it would save like 50 to 100 meg of disk space. And this was, we were doing something on AWS Lambda, and we were caring about disk space. But this is like, I think people often get their back up a little bit and like, oh, I don't want to put too much random stuff in the shipped artifact. But I want to make the argument that putting a markdown version of your documentation in the shipped artifact is a good use case for agents. Now, the other question that kind of we've talked about a lot as a team is, should we be building our should we be creating our documentation differently for agents as the kind of end target of things? And before I talk about that, I want to cover this framework. I don't know if you've seen this framework before. This is something that I've loved and used a lot over the years. But it's this concept that you split out your documentation into these 4 different quadrants. Each page of your documentation should fall kind of clearly into each one of these quadrants. And if you look at the navigation for a documentation website, these should kind of be roughly obvious sections, maybe in your navigation or how you have the flow of the site. So starting from the top left, you have tutorials, right? This is kind of your often you have like an onboarding. You might have like a 10 minutes to pandas or a 10 minutes to whatever kind of notebook that people run through. You have some kind of end-to-end example that is probably some kind of opinionated thing to do with that library, right? And it runs through something, and the goal of that is to do like an end-to-end task and to teach you about the library as you're going along that path, right? Tutorials. The counterpart to that is you have how-to guides. These are like little cookbook snippet recipes, like 10 lines, how to do this small task. And you might have loads of these pages. And they're different to tutorials in that tutorials are trying to walk this long winding path that teaches you all sorts of different things, whereas how-to guides are just like, here's how to do this one thing, get straight there, just almost copy and paste this, Stack Overflow snippet kind of style. You then have, let's go down to reference, right? Reference is typically what we think of as like the auto-generated API reference. I'm going to take all of my doc strings from my code and I'm going to build that into the documentation. You would use Sphinx or make docs or whatever it is that you're building. A lot of that gets made automatically. You don't think about the layout of that or anything. It just kind of copies your code. And that ends up in your documentation. And then you have kind of explanation pages. And sometimes you'll find in documentation this is like weaved all through everything everywhere, but the framework, the Diataxis framework makes this argument for kind of having a separate section of like, why? Why does this library do this thing this way? What is the theory behind the design and the architecture and why we've made this documentation? And out of all of these things, the reference is the only thing that you can really get quickly from looking at the code. Right? You can maybe get some of the how-to stuff from the doc strings. There might be little examples in there, or the tests might have little examples in there that are useful. But a long-winded tutorial is not something you're going to be able to get out of code. And the explanation is almost certainly not in there. Right? The reasoning behind why something's happened, unless it's extremely well commented, you're going to have these like high-level conversations. And you can, to give like explanation a clear example, if you're going to look at NumPy, they have all these neps, right? Or Python, they have all these peps. These are like high-level discussions of design of this project over time. That is documentation for the project, but it's not captured in the code at all, right? It's like a reference thing that the agents are not going to know anything about. So when an agent hits your code, it might get some of the reference, but that's kind of about it. Now, some of you might be thinking like, oh, we haven't mentioned skills yet. Skills is like a thing of how we teach agents to do things. And skills is basically documentation as well. So if you've not used skills, this is a thing that kind of came out of Claude Code and then has been adopted by everyone, where you have a small markdown file that gives a bit of information to the agent on what it can do. And it has a description line, which is like one sentence, and then it has a whole body, which is like the actual information. And when the agent loads, it reads the skills, and it just reads all of those initial lines. And it's like, if you want to learn more about this topic, load this skill. If you want to learn more about this topic, load this skill. And they can do clever things like executing bash commands when they load so that it can get up-to-date information, and they can call scripts and do all sorts of different things. But this is kind of the way that the progressive disclosure concept, like one of the ways progressive disclosure has been implemented in agents, right? Skills are that kind of theory. But they're also like how-to guides, basically. They like fit into that quadrant of documentation. It's like a small snippet that says, this is how you do this task. It doesn't really tell you why or any of the reasoning behind that. It just tells you, like, here's how to achieve the goal that you're trying to achieve. Now, agent skills are great because lots of people are building these. They're shipping them with their libraries. And I would kind of consider building this into your documentation, right? If you're going to have a how-to section, why don't you just make all your skills the how-to section? Just configure Sphinx to just read all the skills and put them in a little list in your documentation website. You're kind of shipping them then in like an agent-first way, skills, and then a human-first way as well. Yeah, skills are recipe. Also, just another little plug, NVIDIA, we have this page called github.com/nvidia/skills. These are kind of our curated skills for doing all sorts of different things. You find a load of like Pydata specific stuff in there, Rapids things. One of the things we've been trying to do is kind of give people more trust around skills, because you end up in a state where you have all these skills installed from all these random places and you're not entirely sure what the agent is going to be reading as it's doing things. I'm going to install this random Python library and it's going to bring some skills with it, and like what's in there. So all of our skills are kind of code signed. They have like you can go and compare the hash. You can make sure that it is exactly the skill you expect it to be. I think this space is going to mature a lot over time, and we'll kind of figure out packaging more clearly, because a lot of projects at the moment, they just you either have like a .agents or .claude or whatever folder, and then within that you have a skills folder, and then you have some skills in there. And those are usually like the maintainer-focused skills, the contributor-focused skills. So when you clone the repo and you want to make a PR or something, it like reads all those skills. And then you'll also see some projects will just put a skills directory like right at the top level, and those are intended to be the like user-facing skills, the skills that like the end consumer of the library could use to be, how do I do a group by or something, whatever that example is, and it explains some more of the documentation in there. Packaging those is still a little bit unclear. There's a nice library now just called, a nice command line tool called skills from Vercel, and there's like the skills.sh marketplace that they put together. So like all this stuff is getting easier to kind of ship, but as a library maintainer, it's still a little bit hard to be like, how do I want to make a skill and I want to get it in someone's hand. I can put it in the documentation. They can get it from GitHub, but like there's still frictions around that. But things are improving. The other thing I kind of want to say on this topic is hopefully you've noticed so far, I asked the question of like, do we need to do anything for writing our documentation for agents? And so far the answer has generally been like, no. Like agents have been trained on our text, the stuff that we write. And so anything that we do that improves our documentation for agents is also improving the documentation for humans, right? Because it's kind of one and the same kind of theory. But one thing I've noticed a lot, especially when you get agents to generate documentation, is they're way more verbose. And they'll explain the same concept multiple times. They might explain it in different ways. And it's kind of just like bulking out that context a little bit to give it like a more solid understanding. And I've seen a lot of examples where sometimes it'll write things and it'll be like really, really terse. And it's like, I don't think I as a person would understand quite what you mean, but you're obviously triggering some words that model particularly liked and understood and has got kind of solid understanding of in its space. And then other things it will describe in a really verbose way, and it's like, well, that's kind of obvious. Like, I don't understand, But it's like every time you write documentation with a model, that documentation is kind of going to be well suited to that model, right? And so I spend a lot of time kind of trying to trim out some of this duplication, trying to clean it up and make it kind of more human readable, but also you need to think about that repetition, right? And this is why I like the diataxis framework, because you are getting this repetition through this way, right? You're talking about the same concepts over and over. You have the API reference, that's kind of a hard technical example. You have the how-to guides, same context, but just like little cookbook snippets. It might get covered in the tutorial as well, right? And it might get covered in some explanation. You're gonna have all these different concepts of the same thing explained in different ways, and agents react well to that. But if you get it to just write the documentation, it might smush all of that into one place. Whereas if you kind of sit down and take a framework that's been well established, it still is very, very useful for your agents. Now there's also, there's this guy called Matt Pocock, if you've not seen him. He's a really good kind of YouTuber who talks a lot about software engineering with AI. He seems to be like, if you've got the spectrum of like vibe code, I never look at the code, and then you've got like full-on software engineering, hardcore practices. He's like way more down that end, but then is going very, very strong with the coding agents, right? So it's like, how can we do rigorous software engineering with coding agents? I really, really like his videos. But the thing I wanted to highlight for this is he wrote this blog post and has this concept on like deep modules. And this is borrowed from other well-known software engineering literature, but this idea that instead of having a very broad API surface for your library, you kind of have some big modules that are very clearly scoped and clearly purposed, that have a lot of functionality built into them with like a small API on the top. And if you build your library in this way, where you have some like big submodules and then you dig into those, and maybe there's some big submodules within those, and you kind of have this hierarchy, agents respond really well again, because it's that same concept of progressive disclosure, right? They'll read the top level API surface. Oh, there's 7 things I need to reason about here. 7 different tasks I could do with this library. I know I'm roughly in this category, so I'm gonna pick that one and read its documentation. And you kind of drill down. Instead of being like, this library can do 200 different things, and then you kind of, all of that ends up in the context straight away. Whereas if you have these big chunks, it will just drill down and kind of pick up the pieces that it wants. So I highly recommend going and watching lots of his work, but this one particularly about modules, because however you end up chunking your code to be readable by agents is going to be useful for chunking up your documentation in the same way. Right? And that's going to come out naturally. As you build your projects, you chunk your code into these submodules, your documentation will just naturally follow that same kind of hierarchy. So you get that benefit from both sides. Now, a couple more kind of little things to shout out is like, please use type hints. Like, type hints have been around for a while. They're wonderful. It makes Python a great language. And agents really like them. It gives them way more information and context about what they can do. Gives them a full idea of the surface of the function that they're calling. I think this kind of Python is very appealing to a lot of people because you can write very minimalist Python code without worrying about all the bells and whistles of the language. But when you're writing code with agents, people love like Rust and other more like verbose languages because the agent is a lot more effective. It can get a lot more information out of that. So my advice would be, if you're writing Python with agents, like use all the features of the language, use the type hints, use all the extra information that the agent can get by reading the code, by reading that API reference documentation, and kind of learning and understanding about the library. The other thing is error messages. Now, I'm a big fan of nice error messages. If you make an error message that doesn't have an actionable next step, that's not useful to kind of anyone. And this is even more true when it comes to agents, right? If you have an error message that comes up and it says this thing has happened, if that error message can say something like, see this documentation page, see this other area, see this troubleshooting guide, or whatever it is, to some kind of information, some kind of context around what's going on, the agent can just follow that, again, like a set of breadcrumbs. So it can write some code, it'll run it, it'll get an error, and it'll go, something's wrong, but it's pointing me to this documentation page. Ideally, that documentation page is local and shipped with the library. It can go and read it and then go, I now understand this concept a little bit better. I'm going to go and tweak the code a little bit more. And then it can do that. You get that nice loop where you don't have to be in the middle of it. It can just keep going. In the same way you would like write tests and they fail and it fixes it and runs the tests again. You can get the same out of error messages, but you need to give it those breadcrumbs of like, where do you look next? Otherwise, it will just start like grepping through the code and things. And it takes a lot more tokens than you necessarily need to. Now, I've like given like a lot of advice about all sorts of different ways that you can improve your documentation, and You can, of course, write tests with doctest. Like, please do that. That's a good thing to do. But when it comes to seeing how agents respond and react, there's so many different agents out there, so many different models out there. I encourage you to just like try these things, explore them, right? Build out your documentation, bundle it up, install it in like a Docker container or something, and put your Claude in there and say, go and do this task that my library does. This thing that I would expect somebody else to ask, and see how it follows, see how it navigates the code, and kind of learn and reason about these things yourself, because not all of these are the same, and it's kind of hard to like empirically test this in the same way that you would with like doc test. Like doc test is great, it can just execute the example and you kind of get PyTest like output. But you kind of want to see like, can somebody take my library and achieve this goal without the model knowing anything about it? And then watch what it does, watch what files it reads, where does it get its information from, where does it learn? Is there any steps where it's like, oh, I wish it had gone and just done this. Maybe I should update this doc string in the top of the file to cross-reference this other documentation file. So kind of spend some time exploring and experimenting with your agents and getting them to follow the documentation, because I think a lot of people are not necessarily doing that. Like, it's very easy to sit on the maintainer side and think like, I'm building a library, and it's sometimes very hard to put yourself in that user side. And it's actually been really interesting as a maintainer, because I don't know how to be a beginner at a lot of the libraries that I work on, because I work on the libraries and I know them inside and out. But it's really interesting watching Claude be a beginner on the libraries that I work on, and it like gives me a bit of insight into how somebody would approach it the first time, especially because a lot of beginners are going to be using these coding tools. Like, it's a way better signal than I would have had in the past. So make sure you're doing that. And basically, the TLDR of this whole talk is just, we invented man pages like ages ago, right? You take your documentation and you put it in a file and you put it on your computer and then you can read it. Like, we should just do that again. And this has come up for me so many times. Anytime I talk to anyone about AI and we talk about whatever the big problem of AI is, we realize that like the Unix people fixed this in the 70s, and you know, we should just kind of go back to a lot of those things. So yeah, the TLDR of this talk is man pages are good. Thank you very much.